this idea of limits, left-hand limit, right-hand limit going to infinity, this brings us to the topic of vertical asymptotes. So let's start off with a bit of a definition here. If a function f of x approaches infinity, either positive or negative infinity, as x approaches c, which c is some real number, from the right or left, then the vertical line, that kind of looks like it's, there we go. The vertical line at x equals c is a vertical asymptote of the graph of f. Now, note here, if f has a vertical asymptote at x equals c, then also we have the idea of continuity here. F is discontinuous at c. So, let's take a look at a quick graph here that I believe we already looked at this one, but just as a quick example, x minus 3 squared. Now, we know that this is going to look like, see, when x is 3, this is 0. 1 over 0 is undefined, and that is where I'm going to end up with my vertical asymptote. And because this is squared, the denominator is always going to be positive. It approaches 0, so it's going to look like this and like this. X and y. Oops. X and y. There we go. So here's my vertical asymptote. So let's refine this a little bit with a little bit better definition, or theorem actually, for vertical asymptotes. Let's let f and g be continuous on an open interval containing c. If f of c is non-zero, g of c is 0, and there's an open interval about c such that g of x is non-zero for all x not equal to c in that particular interval, then the graph of the function given by h of x equals f of x over g of x has a vertical asymptote at x equals c. Now, that's a mouthful. Let's just figure out what that just said. So let's just take a look at that previous one we just did. And this is h of x in this case is equal to 1 over x minus 3. Actually, the one we just did was squared. That's not. Who cares? It's the same idea. So in this case, f of x is 1, and g of x is x minus 3. And in this case, c will be equal to 3. Okay, so what's going on here? When c equals 3, g of x equals 0. Let's write these over here so you can line this up with the definition a little bit better. So at g of c is g of 3. 3 minus 3 is 0. So at c, at 3, I have 1 over 0. And that's what this is saying up here. For f of c non-zero, so f of 3 is 1, it's non-zero, but g of c, g of 3 is 0, and there's an open interval about c such that g of x is non-zero, and there's an interval up about x equals 3. I can make that as small as I want, and it's defined, it's non-zero, and it's defined. So what that tells me about this definition here is that that's what's going to give me my vertical asymptote. Okay, so that should pretty well cover the idea of the definition. What we need to do here, I think, in the next video is we'll take a look at some examples.